So as an object, it's dropping from a building. Here's my building. And here's my object. And shoop, it's going down. And so the rate at object drop. So y in this equation, y equals 16t squared, is telling us how many feet it's fallen after t seconds. So if you plug in t equals 2, it's fallen 64 feet. If they ask for an average speed, an average is just a slope, okay? So if you were to make a graph of this function, it's t squared, right? And I'm not going to even bother drawing the negative side of it. So it's quadratic. So after 1 second, so at t equals 1, we've got 16 feet. It's fallen, right? After 2 seconds, then 2 squared is 4. 4 times 16 is 64 feet. So you can keep going, obviously. An average speed is a slope from a starting time point to an ending time point, and that's it. That's all an average is. Okay? Because when you first drop that item, it's not moving very fast, right? It exits your hand, starts at a velocity of 0. Gravity pulls it down, starts going faster. Faster and faster as time goes on. So time t equals 1, we've traveled 16 feet. Time t equals 2, we've gone more than 16 feet. We've accelerated our decline. We've traveled 48 feet down at that point. So it's speeding up. The average speed is just the slope between the starting point and the ending point. So just to give us a rough idea of how fast it's fallen. So all you have to do is take the fact that it starts at time 0, t equals 0, we've traveled 0 feet down. At a time t equals 4, so somewhere way up here on my graph, at t equals 4, then we've traveled 4 times 4 times 16. We've traveled 256 feet, right? So the average speed is the slope between those 2 points. So 256 divided by 4. We've gone 64 feet over 4 seconds. 64 feet per second over those 4 seconds. That's the average speed. Okay? And again, just to emphasize, because this is the calculus part that's coming up next, okay? The algebra part and the caveman approach is to say, hey, you start at time 0, we found out we've traveled 256 feet after 4 seconds. Obviously, this isn't a caveman, but that's an average of 64 feet per second over those 4 seconds, okay? That's just a rough average. The calculus part is to say how fast it's going at this instant, right? Because when is this object falling faster? Is it falling faster at t equals 1 or at t equals 2? When does it have a greater speed? At t equals 2 it has a greater speed, right? Because the more time goes on, the faster this object is falling. At t equals 0, when it first leaves your hand, it's got a speed of 0. At t equals 1, now we're picking up some speed. Within 1 second, we've traveled 16 feet. At t equals 2, well, now we've traveled, what did we say? We traveled 48 feet within a second. So that's the calculus thing, is to find out how fast you're traveling at that instant, not taking an average. Okay, and in order to do that, the textbook is kind of ambitious here. It's giving you this problem without giving you the exact tools on how to find this instantaneous rate of change. But the big idea is this: you want to find a slope between 2 points that are really close to each other. So let's say 3.9. We'll find out how far we've traveled, and at t equals 4. So like on this graph, so let's say this is 2 and this is 4, and forget these numbers, get out of here. It's like I picked 2 points that are really close to each other. That gives us the slope, the average slope, that's really, really close to one another. So that's giving us a good idea of how fast we're traveling at that instant. So at t equals 3.9, we got to square that. Then times 16, we've traveled 243.36 feet. At t equals 4, we already plugged that in. We traveled 256 feet. So what's the slope between those 2 points? 4 minus 3.9. We've got 126.4. That's how fast we've traveled over 0.1 seconds, right? Now pick a point that's a little bit closer. Pick 3.99, and then we'll find how far we've traveled. If you plug in 3.99 into our equation that tells us how far we've traveled, you've gone 254.72 feet. 254.72 feet. And now if you recalculate the slope between these 2 points, what was it, 72? Bad handwriting. That's going to be 128. And if you, wait a second. Shouldn't be on the nose because that's actually 250. Oh, it is. Okay, because I rounded. Okay, because of rounding. Wait, I did subtract. Okay, that's 128. So we got 128. So if you pick another point, 3.999, look, these slopes are getting really, really close to this number. The next point you pick, you're also going to get 128. If you pick 3.999, go ahead and do that. Find out how far we've traveled, and you'll see that it's getting really close to 128. So that's the calculus part, is we get infinitely close without reaching something. So what's the speed at t equals 4? It's 128. Okay.